When you watch an educational video, it's hard to tell how much work and thought and research went into that video. In reality, a good educational video has been based on research that has been done over decades into the effect multimedia has on learning. In fact, Professor Mayer at UC Santa Barbara has drawn an ever-expanding set of principles from this ever-expanding body of research. The key principle is the Multimedia Principle, which states simply that words together with graphics, which is called multimedia, leads to better learning than simply words alone. In order to really understand why this would be, however, we first need a basis in cognitive theory. So in this video, we will discuss the cognitive theory behind multimedia learning, and by the end of this video, you should be able to describe the 3 key assumptions this is based on, as well as differentiate between the different types of processing that our brains utilize while learning from multimedia. Mayer's cognitive theory of multimedia learning is based on 3 assumptions. First, the dual-channel assumption is that learners process information through separate channels based on whether it is audio or visual, and whether it is words or images. Information taken in via the visual channel can be written words or graphics, for example, while verbal words are taken in via the auditory channel. However, after they have been taken in, all words are then thought to be processed together in a separate channel from graphics. Interestingly, expert learners may have the ability to form mental pictures from words and mental descriptions of images, thus allowing these bits of information to cross over from one channel to the other. Second, the limited capacity assumption states that any channel has a limited capacity for material at one time. The visual channel may be overloaded by putting both graphics and significant text on the screen at once. Likewise, asking the brain to process both written and spoken text at the same time is not ideal. And third, the active processing assumption is that in order to learn, learners must pull out relevant bits of information from the information they receive, and organize and integrate them with respect to each other and to their prior knowledge. Our brains do not have the ability to passively process all of the information we're given and then play it back word for word. Rather, we actively decide what parts of the material are relevant and important and weave those into our knowledge scaffolds. While trying to learn from different sorts of material or situations, our brains perform 3 types of processing. These are extraneous processing, which drains cognitive capacity without learning. Essential processing, in which we are pulling out relevant information from what we take in and organizing it in our working memory. And generative processing, in which our brains reorganize new information and build upon our prior knowledge scaffolding. Through use of instructional design techniques, we can alter what sort of processing our students go through. Our goal is to reduce extraneous processing, which wastes our cognitive capacity, manage essential processing, allowing us to take in information more efficiently, and foster generative processing, which leads to deeper understanding and retention. So how can we apply this cognitive theory to effective multimedia creation? Lots of research has led to Mayer's principles of multimedia design. Some of these principles work towards the goal of reducing extraneous processing, for example, the coherence, signaling, redundancy, spatial contiguity, and temporal contiguity principles. Some of the principles work towards the goal of managing essential processing, for example, the segmenting, pre-training, and modality principles. And some of the principles work towards fostering generative processing, for example, the personalization, voice, and image principles. To learn about these principles and how to apply them, if you haven't already, watch our companion video on Mayer's Principles of Multimedia Design.